rational fractional expressions. So what we're really doing is essentially adding fractions. And the best way to think about it is just like how we used to do, adding fractions. What do you need in order to add fractions? A common denominator. We need common denominators. That is very, very important. And I want to just always say, factor first. All right, factor first. I love alliteration. It is my very, very most favorite thing here. Here, number 7, these are actually 4W and 5W. This is like 4 times W. And we have 4 times a W, and we have 5 times a W. They are technically already factored, okay? That's kind of be like 4 times 7 and 5 times 7, okay? Now, when we think about common denominators, you'll notice I use colored. Here, I had a purple 4, a red W, a pink 5, and a red W. I want basically all the colors. So my denominator, I have a purple and a red. What do I need? A pink. Yes, I need the pink 5. And of course, if I multiply that denominator by 5, what else do I need to do? Do the numerator also, because that would be like multiplying by 5 over 5. And what is 5 over 5? 1. Okay. Now, on my second fraction, I have the pink and the red. What do I need? The purple. I need the purple 4, top and bottom. So this is what we're doing. We're just making sure that we got all the color. Life is much more exciting when it's colorful. And we can rewrite those fractions then. I get my numerator of 15 over 20W minus 8 over 20W. And now that the denominators match, what is 15 20ths W minus 8 over 20W? 7 over 20W. I don't know what that means, but that is it. And of course, we would want to look to see if we could reduce, but that does not reduce. So that's it. Number 8 here. What's the denominator on 3? Yeah, we do have a denominator of 1. And x plus 4, this in and of itself is its own little factor. Because it's connected by addition, it doesn't break apart. So that is a factor. And our other denominators are 1. And again, I need a little bit of both. So I could multiply this first fraction by 1 if I wanted to, but that's not going to change anything, is it? All right, what do I need to multiply the second fraction by? Yes, the whole factor x plus 4, top and bottom. And I'm encouraging you, ladies and gentlemen, to write it in because you'll just do better here. The denominator now, this first fraction is going to stay the same. It's 2x minus 1 over the x plus 4. But my second fraction, I have to do -3, and I'm going to distribute that in there. What is -3 times x? -3x. And -3 times +4? -12. Now what I'm going to do is simplify this, is say, hey, that is all the stuff in the numerator. I don't actually have to write the 2 separate fractions. It actually makes it a little bit harder. They both have a denominator of x plus 4. So really, I only have to worry about the numerator, and the denominator is x plus 4. Okay? From there, I just need to combine like terms. 2x's minus 3x's is -1x. And we have a -1 and a -12, -13 over x plus 4. Okay. Can I cross out the x's? No. That is it. Okay? So once you make the denominators match, we really just care about the numerators. All right? Let's try quite a few more. Those were the easy ones. factor first. And by factor first, I really care about those denominators. So right here we have r squared minus 25. How does that factor?
R minus 25,
Almost. Yeah, there we go. R minus 5 and R plus 5. R minus 5 and R plus 5. So again, that double bubbles there. And you'll notice my other fraction already has that denominator of R minus 5. So they both have the R minus 5. What does the second fraction need? The pink. It needs the pink R plus 5 on top and bottom. So I'm going to multiply by R plus 5 on top and bottom. Do I have to do anything to the first fraction? No, because it already has that pink factor already, so it has everything. All right? Do our denominators match?
Yep.
They both have the R minus 5, and they both have the R plus 5. So now I already have my common denominator, and I just need to worry about my numerators. So I have for my first fraction R plus 5. My second fraction, I'm distributing my 6 to the R plus 5. What is that going to give me? 6R plus 30. Yep, 6 times R is 6R. 6 times 5 is 30. And then we just need to combine like terms. What do we get there? 7 R's. All right, so I get 7 R's plus 35 over R minus 5R plus 5. Are we done? Ooh, why not? We can reduce. There is a greatest common factor here on the top. 7, so we can take out a 7. What happens when I take that 7 out of both terms there? We get R plus 5, good. So we undistributed. And then we have still our denominator was R minus 5, R plus 5. And yes, now we have a common factor, top and bottom, that will reduce. And so what are we left with? 7 over R minus 5. Beautiful. Okay. All right. When I look at number 10, what do you notice about the denominator? They're the same kind of. Yeah, double bubble. The same but like totally different? Is that what that means?
Same, but like 50%.
Oh, 50% the same. Okay. All right. So how does a squared minus 4 factor?
A plus 2 and A plus 2.
A plus 2 and A minus 2. Yep. All right. And so my second fraction has that denominator already of A plus 2. So there's the match. And then what do we need to multiply our second fraction by? Yeah, we already have the purple A minus 2 on the first fraction. I need the purple A minus 2 on the second fraction. So now they have both parts. All right. What's my common denominator? Good. A plus 2 and A minus 2. Now you multiply that out, Ellis. I'm going to leave it factored because ultimately I'm going to have to see if I can factor and reduce. So we want to leave bubbles. I'm going to combine my numerator. Let's see, that would be 5A plus 6 for the first fraction. What do I have to do on the second fraction? Distribute what? Is it a 1 or should we distribute a negative 1? Yeah, distribute the negative 1 and you'll make far, far fewer mistakes. This is a huge mistake area right here. Negative 1 times A would be negative A, and then negative 1 times negative 2, positive 2. All right, let's see. That gives me my, good, 4A plus 8 over A plus 2A minus 2. All right, what do you notice about that numerator? Greatest common factor of 4. Very good. So we're going to factor out the 4. What's left behind? A plus 2 is left behind. Over A plus 2 and A minus 2. Good, good, good. And we do see that we have a match. Top and bottom, common factors that reduce. So we're left with 4 over A minus 2. Beautiful. All right, how are you doing? Are you doing okay with this? Very good. Doing okay? All right, number 11. Are you writing this down, Alice?
Me? Yeah. Go check what? Who he is.
All right, what needs factoring on number 11? The right side, the right one, yeah. Double bubbles, we have a trinomial. Q minus 4 is already a factor, q to the first power, but if you see anything with a squared on it, we can probably double bubble it. All right, let's see. Q times q is q squared. What times what gives us that positive 12? 6 and 2, 4 and 3, or negative 4 and negative 3. That's the winner right there. All right, so, ooh, this one's more challenging. It looks like they both have a q minus 4, but our second fraction has a q minus 3. So what do I need to put on to my first fraction here? Yeah. So we need a q minus 3 on top and bottom here so that they both have a pink and a purple factor. What do we have to do with the q minus 3 times the q plus 1? Yeah, we've got to FOIL those together. So, that's going to be a lot of work. Let's see, my denominator is q minus 4 times q minus 3. And I have to multiply these bubbles together. That's going to give me q squared. The outside and the inside make what? Negative 2q, yep. So the outside is 1q and the inside is negative 3q. And when you combine those, you'd get negative 2q. And then last times last would be negative 3. And then this is tricky. We have a minus, but we're subtracting this whole numerator. What do we have to do with that negative? Yeah. It's as if this was a factor, and we have to distribute that negative to both things in the numerator. Okay? So this becomes negative q, and negative times negative 1 becomes positive 1. We're subtracting both terms, so you are going to change the sign. Okay? All right, I'm going to do a little cleanup. Let's see. My denominator is q minus 4 times q minus 3. My numerator is q squared. Negative 2q and negative q is negative 3q. And negative 3 and positive 1 is negative 2. Ooh, what do we got to do there? Factor it again. Double bubble that numerator. Q minus 4 times q minus 3 on the bottom. Let's see, q squared is q times q. And what times what gives me negative 2? Negative 2 times ooh. No. Ooh. No. Oh. Yeah, that doesn't actually factor, but we tried, and that's what we needed to do. So it doesn't actually factor, so this is the final answer. All right. Yeah, those had to be opposite signs, so that wasn't going to work. Okay, last one, number 12. Can I factor these denominators, or are they already factored? They're already factored. X plus 6 is its own factor, and x minus 1 is its own factor, so we need each of them. So we're going to multiply the first fraction by x minus 1 on top and bottom. And the second fraction by x plus 6 on top and bottom. All right, my denominator's good, x minus 1 times x plus 6 on both of them. And my numerators I need to distribute. What do I get for the first fraction? 3. Good, 3x minus 3. What am I distributing on the second?
2x minus 12.
What about the negative?
Negative 2x.
Oh, yeah, distribute the negative. Negative 2x minus 12. Take the sign along for the ride every single time. It's going to go so much better every single time. All right, let's see. 3x's minus 2x is an x. Negative 3 and negative 12 is negative 15. And then we have the x minus 1 times x plus 6. And that doesn't double bubble. So this is the final answer. All right, do you have any questions for me?
Complex factors, we're not doing that, right?
Tomorrow. Yeah. This is it for today. Okay. You do have adults in math. What do you need in order to add and subtract fractions? Common denominator. And what do you want to remember about those denominators? Factor first, every single time. You will want paper, so get out a piece of paper.
So I'm not going to be here tomorrow.
Okay.
For this class because I have an ortho appointment.
Okay.
Is it just a complex? And I'll be on.
Yeah, and you'll find it under
Yeah, ask his sisters. Yeah, he's like, what? And they're like, go.
Is 1.7? Watch this.
1.7, yeah. It's Duncan Mass 1.7, 1.7.
Do you know what the SSUI schedule is going to be?
You want to know the timing for it?
Yeah, because I'm going to miss other classes and I don't know which one.
Yeah. I will. Okay. Yeah. I think. Oh, it's actually a worksheet. Maybe. I don't change it. I do have it if you want the paper. Yeah. But I might. I'll change the calendar if I say that we get to do around like 6. I don't know.
Why'd you make us do 6 on the hard one?
Oh, I think I changed it. I think that's what it. Oh, no, we didn't. Yeah.
Which card did you grab?
That's easy.
through the text.
Okay, there you go. Yeah, I was like, you already did it.
Have you done psychology in college yet? Or the impact that's just 19 or
Oh,